Question number 4, draw the valence structure for the following compounds, including any non-bonding lone pairs. Name the VSPER shape for each molecule. Pretty straightforward here. What we're starting off with is a Lewis dot structure to think about it. I can see 3 areas for bonding here, so it's going to be nitrogen to 3 hydrogens with a lone pair at the top there. Here we're going to have carbon, which is like this, and then let's have a look at these other ones. Hydrogen's got 1, fluorine is a halogen, so it's going to have 1 bond as well. So I can see the fact that we're going to end up with H's and fluorines there. Fluorine, however, has 3 non-bonding pairs happening. Phosphorus looks exactly the same as our nitrogen because it's in group 5, so therefore we're going to end up, oops, this is going to go to F though, isn't it? Remember, fluorine had 1 unbonded pair, and therefore that. Each fluorine will have 3 lone pairs of electrons, and this guy, probably seen it before in class, but ends up looking like this because our hydrogen has got a single bond it can form, and oxygen has 6. So therefore it can form 2 bonds, and putting it together you end up with this molecule here. Now that's not the end of the question. It says what is the VSPER shape, the valence shell electron pair repulsion shape for each molecule. This guy here is a triangular pyramid, if I can write pyramid properly. Okay, he's a triangular pyramid. Likewise, this guy is as well, same thing, triangular pyramid here. This guy here would be tetrahedral. Triangular pyramid because he's got 1 lone pair. That makes it a triangular pyramid because it pushes these hydrogens coming down. So therefore it makes a triangular pyramid. This has got the same thing, 1 lone pair about the central element. It has this. Tetrahedral because there is no lone pairs about the central element here. This guy's a bit weird because he's got more than 1 central element, but let's just call it V-shaped because about each of these oxygens you would have this V-shaped thing going on here. So we'll call it V-shaped because each of these oxygens has 2 lone pairs, and it's the most logical answer to that. Question B, which of the above molecules would be able to exhibit hydrogen bonds? Hydrogen bonds come from polar molecules which have H to O, H to N, and H to F. So therefore, looking at this, I've got NH3, and I've also got H2O2, which is interesting. It's not going to be this guy here because he's got the fluorines bonded to the carbons. The fluorine is not bonded to the hydrogens. So therefore, although he does have hydrogen and fluorine in the molecule, it's not actually attracted to each other. So therefore, it doesn't have that fancy pants dipole-dipole bond, that extreme polarity about a bond within the molecule. So the only ones to exhibit hydrogen bonds would be ammonia and hydrogen peroxide. Label the diagram below to show the difference between an intermolecular and an intramolecular force. Well, these solid lines here, these are intra, and this dashed line here is an intermolecular force. This is between atoms inside a molecule, and this is, that's our bell, between molecules, between molecules. Explain how an intra bond is created. Well, this intra bond is a covalent bond between shared unpaired electrons. That's how the bond is formed. That's how the bond's formed. It's formed when unpaired electrons are shared. And that's the answer there. That's the answer for question 4. And question 5 will be next.